Hi everyone. In this video, we are going to discuss about the nature of roots of a quadratic equation. In a previous video, I have discussed the quadratic formula, which helps us find the value of the roots of a quadratic equation. But without calculating the value of the roots, is there a way to know about the nature or properties of the roots of a quadratic equation? Let's find out. If the quadratic equation is ax squared plus bx plus c equals 0, then we know that the two roots of the equations are alpha equals minus b plus square root of b square minus 4ac by 2a, and beta, which is the second root, is equal to minus b minus square root of b square minus 4ac by 2a. So the two roots kind of look like this, right? Now if you carefully look at it, you will see that there is one particular portion of this value which kind of look identical. For example, if you simply look at this part of the value, it is actually identical between the two roots. Let me highlight it on the other side also, that way you can clearly see it. So the value of the roots, they look kind of identical partially, but there is only one part of the value which is going to make the difference, and that part is actually this portion, the red highlighted portion. This is the part of the value of the roots, right? This is the part of the value that is going to make any difference in their values. Otherwise, their value would be identical. So if that red box, if the square root portion disappears, then if you look at it, that the alpha and beta, they will have the same value, they will have identical values, right? So whatever is within that square root, that is the actual differentiating factor when it comes to the values of the roots. Now whether the values of the roots will be equal or unequal, whether they will be rational or irrational, whether they could be real or complex, all of that actually going to depend on this b square minus 4ac. That is the differentiating part of the value of the roots of this equation, right? So that is why this b square minus 4ac is actually called the discriminant, and it is denoted by d. Now let's use the d notation in place of b square minus 4ac, and let's write down the two roots of this quadratic equation. So we can say alpha is equal to negative b plus square root of d whole divided by 2a, and similarly beta is equal to negative b minus square root of d. Wherever we have b square minus 4ac, we are writing the d, which is the discriminant, right? That's the discriminating factor in the values of the two roots of this quadratic equation. So now let's do a little bit of study about the roots depending on the value of the discriminant. Now suppose that the discriminant is less than 0. Let's take the first case where the discriminant is less than 0. Then what would be the values of the roots, or what would be the property of the roots? Well, if you think about it, if the discriminant is less than 0, that means if d is negative, then we have a negative number inside the square root. In both the cases, for alpha as well as beta, we will have a negative number inside the square root. That means that will turn into an imaginary number. So our entire root will become a complex root, right? And once it becomes a complex root, obviously because of the plus sign and the minus sign before the square root, the roots will be different. They will be distinct roots. So in this case, roots will be complex root, they will be distinct roots, and because we have the plus and minus right before the imaginary portion, the roots will also be complex conjugate. Now let's talk about the second scenario where d is equal to 0. In this case, as you can see from the values of the roots, if d is 0, the square root portion disappears. That means if the square root portion disappears, then they will be left with the negative b divided by 2a. Here also for alpha it will be negative b divided by 2a, and for beta also it will be negative b by 2a, because the square root portion will disappear, because when d is 0, the square root of 0 is 0. That means that portion disappears. So then we can see that the values of the roots will be equal. So in this case, the values of the roots will be real and rational, and also the values will be equal. Now let's talk about the third scenario where d is greater than 0. Well, when d is greater than 0, as you can see from the values of the roots, if d is greater than 0, then the square root portion is not going to disappear. It is going to stay there, Now that may turn into an irrational number, or it may be a rational number depending on whether D is a perfect square or not. So there is a possibility that D could be a perfect square or D may not be a perfect square. If D is a perfect square, then obviously the root will vanish and we'll get a rational number there. But if D is not a perfect square, then we'll get an irrational number there, right? So in this case, the nature of roots will be, obviously we will get real roots, and the values of the roots will be different because the square root portion is still there. For alpha it will have the positive sign, for beta it will be the negative sign. So the roots will be different, and also if D is a perfect square, then we get a rational root, and when D is not a perfect square, we get an irrational root. So let me write it down here, and also let me write down what happens when D is a perfect square. Now let's take an example for each of the cases. So what I'm going to do, I'm going to write it right here. Let me use a different color. Let's say I'm going to use the green color here. So if you have an example, suppose we have a quadratic equation which is x squared minus x plus 1 is equal to 0. In this case, as you can see, that a is 1, because if there is no coefficient in the leading term, that means the coefficient of the leading term is 1. No coefficient means the coefficient is 1, and then b is actually equal to negative 1 and c is equal to 1. So d will be, so we can say d will be equal to b squared minus 4ac. That means negative 1 squared minus 4 times 1 times 1, which is equal to 1 minus 4, that is equal to negative 3. So in this case, you see, for this particular quadratic equation, the discriminant is a negative value. That means the roots of the quadratic equation will be complex roots. There will be a real part and an imaginary part. The square root portion will become an imaginary part, and of course the roots will be complex, and the roots will be distinct, meaning they will not be equal, they will be different. And because it's a complex number, because of the positive sign and the negative sign, so in one root we'll have the complex portion as positive, in other root imaginary portion will be negative in the other one. In one of them the imaginary portion will be positive, in the other one the imaginary portion will be negative. So the roots will be called complex conjugate. They are actually called complex conjugates. So the roots will be actually complex conjugates. The two roots will look like complex conjugates. Let's take an example for the second case. Here, for example, we have an equation x squared plus 2x plus 1 is equal to 0. Now here, what is a? A is actually 1. No coefficient means coefficient is 1. B is actually 2 and C is actually 1. So here D will be equal to b squared minus 4ac, that is 2 squared minus 4 times 1 times 1, 4 times a and c. So this will be 4 minus 4, which is equal to 0. Now in this case, you see that the value of d is 0, the discriminant is 0. That means the roots will be equal. There is no differentiating part of the value in the quadratic formula, right? So as soon as d becomes 0, the square root portion disappears. That means the values of the roots will be equal. So right here, as you can see, when d becomes 0, then alpha also becomes negative b by 2a, beta also becomes negative b by 2a. That means the roots will be equal, and of course they will be real number and rational number. There will be no irrational portion there. Everything will be rational and real. Now let's take an example for the third situation. First we'll take this example. Suppose our quadratic equation is x squared minus 3x plus 2 equals 0. So here a is equal to 1 because the coefficient of the leading term is 1, and then b is equal to negative 3, which is the coefficient of the x term, and then c is equal to 2. So here d will be, the value of d will be b squared minus 4ac, which means negative 3 squared minus 4 times 1 times 2, right? That means 9 minus 8, which is equal to 1, which is actually, as you can see, it is actually 1 squared. We can write 1 as 1 squared also, right? So in this case, d is obviously positive and it is a perfect square. And because d is a perfect square, the value of the roots will be rational. They will be rational numbers. Now let's take another example. Suppose we have an equation x squared minus 5x plus 5 equal to 0. Now here you can see that a is equal to 1, b is equal to negative 5 and c is equal to 5. So what will be the value of d? Well, d will be b squared, which is negative 5 squared, b squared minus 4 times 1 times 5, right? That is equal to 25 minus 20. That is equal to positive 5. So in this case, d is also positive number, but it is not a perfect square. That means now the square root is not going to disappear. The root will still hang in there and it will make the value of the roots as irrational number. The roots will not be rational this time. In this case, the roots will be irrational numbers. I hope everything made sense. Thank you for watching. See you in the next video.